All right. Good morning, everyone. I hope you're doing fine, and I hope that you are safe. Positive vibes are everywhere, that things are getting better. So I certainly do hope so. Today is day 19. We still have 11 days together, and today we're doing a summary of our week 3, which was about general manufacturing. Week 4, we're going to focus on automated fiber placement. We're going to take details on the defects, the inspection, the programming, and different aspects of the design, different aspects of automated fiber placement. Good morning, Venkatesan, Ganesh, Chris. It's awesome to be back connected. So let's go ahead and get started. So today is not a traditional lecture like the usual ones. Today is where we take all the questions that we had in the week and we recap them and we try to, make a conclusion on the manufacturing aspect of the course that we've had together. Good morning, Emra and Elio. All right, let's go ahead and get started. And on week 3. Hello, Katrina. So week 3, this is what we've covered. We've covered a lot. We've looked at hand layup. We've looked at spray up processes. We've looked at filament winding, thermoforming. We had coverage of the AFP and ATL processes. So we basically covered almost the most common composites manufacturing technologies. And also we had an awesome lecture on virtual manufacturing from Convergent with Stanesh on Friday. So this is a little bit, we've covered a lot in week 3. Now let's go ahead and start recapping what we've covered. We have 10 questions that are from the lectures that we've had so far. And this is a kind of a good recap for us to go through. True or false, hand layup is a manufacturing process with low upfront costs. So what do you think? Go ahead, show me on the chat. Do you think that hand layup is a manufacturing process with low upfront costs? In comparison, AFP, which is one of the most complicated composites manufacturing technique, you have to invest millions to get machinery and skilled technicians and programmers and so on. So how about hand layup? Do we have upfront costs? Are they low? Happy morning to you as well. Hello, Giselle. All right, I can see Ganesh, Venkatesan, Katrina, you're answering the right answer, which is Elio. True, that is correct. It is true. Manufacturing with hand layup does not require upfront costs. It's very, very minimal. And you can actually today purchase a couple of fiberglass and resin epoxy and just go ahead and start building your first hand layup composite. All right, moving on to question 2. So far, so good. Ashish, good answer. All right, awesome. Kofi, Rahman, it's very awesome to see new names today in the course. This is building up to be a great community for composites. Question 2, spray up feeds which one of these materials through the chopper gun? Is it chopped fiber, pre-preg, or continuous? So we're talking about the spray up process where you're holding the spray up gun and you're shooting to the part. So what is the kind of material that we have through the chopper gun? All right, I can see the answers trickling in, saying chopped and saying A. Ganesh, that's correct. Katerina, Raman, Venkatesan, that's awesome. So yes, it is chopped fiber. Keep in mind that sometimes what we have is a continuous roving coming to the gun, but within the chopper gun, you are chopping the continuous, and then you're delivering them into chopped fiber. Sank, that is awesome. All right. Moving on to question 3 out of our 10 questions. Multiple answers through gun continuous, but when spread, it's chopped. I agree, and that is Gohil. That is exactly what I just mentioned. It is before it comes to the gun, it is being fed as continuous, but within the gun, it is spread up and it is delivered as chopped. All right, awesome, Giselle. Question 3, true or false? In the image below, the fibers will be twisted as they wrap around the mandrel. So I'm going to go ahead and tell you a little bit. If you have twisted fibers, you are going to have failure and you're going to have issues. So the mere fact of asking this question in a way, it's like asking you, do you even accept to have such a defect, which can be detrimental on this is a filament winding process. Would we accept to have that? So let's see the answers. Venkatesa, Katrina, Elio, Ganesh, Raman, Piyush, all of you answered false, and you are right. This is false. We cannot tolerate having twisted fibers. Twisted fibers is a defect that actually is very detrimental to the fibers themselves and can constitute a point of failure that might be problematic. All right, question 4. Will the final part cost for filament winding be higher, lower, or the same as hand layup? And as we remember, we're going to say we're producing 1,000 parts, because the answer to this question can be 2 answers. If we're producing 1 part, you can have 1 answer. But if you're producing the amount of parts that you would produce, usually like 1,000, hundreds parts, then the answer is very, very clear. So what do we think? Is it going to be higher, lower, or the same as hand layup? All right, let's see some of your answers trickling in. All right, I see some B's coming up. I see lower, that's good. Do we have software? Definitely, we do have software, yes. We have software to program, and actually in a lot of time in these manufacturing techniques, you program something, you simulate it, and then you run a lot of acceptance trial to make sure that, all right, everybody's lower, saying lower, I agree. Coffee, Ganesh, Venkatasan, Raman, all right, awesome. So yes, it is lower. Question 5. So we are midway into our little summary of the week today. Which of these is not an advantage of thermoforming? Remember the concept of thermoforming, where we have the closed mold process and we are trying to. So I'm going to answer one of them is A. We're actually trying to have a process that ends up in few minutes, so it's a fast process. So which of these is not an advantage of thermoforming? We know by now it's not A, because I just said it. Complex parts are possible. Final parts are not strong. High production rate. So what do you think? A, B, C, or D? What do you think is? So if you're joining us now, as people are answering on the chat, so if you're joining us now, this is on Sunday. What we do on Sunday is all week long we have regular lectures every day at 12 noon EST, and you have the different times in different time zones. And on Sunday, what we do is we take questions from the day and from the whole week, and we try to make like a week recap before we move on to the next week. And we are fast approaching the end of our months-long course. So let's see what people are saying. CC, I see a couple of these. Actually, it has a high production rate. It is a fast process and it has a high production rate. You can produce parts like as quick as 30 parts a minute. Of course, it depends on the complexity. The right answer for this should be C. Final parts are not strong. Actually, thermoforming produces decent strengths in parts, and you can create complex parts. They can be fast production and high production rate. All right, moving on to question 6. So question 6, we're talking about Tooling cost. Since the capital and tooling cost are high, the final part cost is also high. Let me, before you go ahead and answer, let me a little bit explain more the context of this question when we had it this week. We talked about several manufacturing processes, and then we talked about some manufacturing processes where you have to invest machinery and expensive machinery, and you have to invest tooling and expensive tooling. And the question in here is, since these are high, then the final part cost will also be high. What do you think? Is this true or is this false? Like, in the context of AFP, if this was about AFP and not about thermoforming, so this was relevant to thermoforming. In the context of AFP, the answer would be true, because in the context of AFP, the material is very expensive, toes, and the autoclave after it is expensive, and the treatment and the inspection and. In the concept of thermoforming, you are producing the complex shape almost instantaneously, and you have little to no finishing afterwards. And I see most of you are answering B, and that is correct. It is false, because we are producing so many parts, we absorb so much of this capital and tooling cost into the part. All right, awesome. I see several right answers. Venkatasan, Katerina, Piyush, Kofi, Elio, this is awesome. All right. Question 7, in vacuum assisted resin transfer molding, so VARTM. Remember, in VARTM, what we have is you put your material, you put your fabric, you put something on top of it. So this is what we're asking, is what is this thing on top of it? And then we cover all the way, and then we have these inlets and outlets in order to do the infusion. So what is the thing that we put on top of the fiber? Is it the flow media? Is it the spiral tube? Is it the vacuum bag? Or is it the peel ply? So what do you think it is? Drum rolls. All right, Mustafa, yes. D, that is correct. Ganesh, Katrina, excellent, 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 excellent. Yes, it is the peel ply. This is the layer that we put on top of the dry fiber. It enables us to have this level of confidence between the fabrics that we have and the other elements, the breathing material and the closing material and all the inlet and other elements. All right, awesome. Now let's move on to question 8. Which of these processes uses a highly reactive 2-part resin? If you remember, we talked about these 3 processes. We talked about VARTM, we talked about RTM, and we talked about RIM. So which one of these processes uses a highly reactive 2-part resin? Is it A, B, or C? Drum rolls. All right, I think there is a little bit of lag because I see some answers coming still for the previous one. It's all right. Thank Elio, I just got your answers for the prior question. They're correct. Yes, that is correct. RIM, this is a process that uses the highly reactive 2-part resin. The term is highly reactive. All right. Let's start wrapping up today's lecture with the last 2 questions that came from yesterday's lecture on automated tape laying and automated fiber placement. Yesterday's lecture was excellent. The amount of comments and reactions, and we even went all the way to 30 minutes. So that's good. Although I try to limit myself to 15 to 20 minutes, sometimes it's just not easy. All right, question 9. Which of these process parameters is not relevant to ATL AFP? Is it temperature? Is it temperature, the heaters that you can heat the part? Is it speed, the speed with which you're doing the layup? Compaction, the force of pressure to do the adhesion and or toe tension or other. So which of these process parameters is not relevant to automated fiber placement? All right, let's see some of your answers. All right, let's make sure that I go back to where I can see the answers. All right, Paul Thompson has answered E. All right, there's so many E's. Oh, that's awesome, all of you. This is great. Yes, it is other. All of these four process conditions are crucial for automated fiber placement. All right, question 10, and the final question from week 3 before we move on to the final stretch of our course. Composites week 3 summary. Question 10, true or false, all defects, and tomorrow we're going to be detailing AFP defects, must be repaired before manufacturing can continue. Is this true or false? All right, let's see some of your answers. All right, I see a lot of new names, and this is awesome. Say it, Fuad. You're welcome to the class. I see Abdullah El Najm. I see so many new names. You are more than welcome. As a reminder, before we go ahead and go through the final answer, there is a place on my LinkedIn at the top where you can access all 19 different recordings from the lectures so far. And the answer to this one is false. There are some defects we cannot go without. There are some gaps, some areas where there is nothing we can do. We have to accept them. Of course, some other defects such as splices and whatnot, we do repair them. We can easily do that, but sometimes the gaps, what's between the different layers is not that easily correctable. So this wraps up our week 3. We talked about hand layup, which is one of the first techniques used to manufacture composites. We talked about filament winding, which has axial symmetry. If you have axial symmetry, you are capable of doing this filament winding process. Thermoforming, where we use heat to shape and cure the part. Infusion, that is dependent on permeability, viscosity, and pressure, and all of these different elements. And finally, we covered AFP and ATL, which are highly automated manufacturing processes. Tomorrow, we start a streak detailing automated fiber placement, and we will talk about defects, we'll talk about inspection, we'll talk about programming, and so on. Tomorrow is day 20. We are strong. We're continuing this. We're going to finish it up very, very strong. Give a round of applause for all of us. I'm going to go ahead and do it myself as well. This is basically something that I never thought we can do. I never thought we can really pull it. And here we are on day 20. And from all over the world, we're doing this composites course together. Thank you so much. And I will talk to you again tomorrow at the same time. Bye-bye.